The James Webb Space Telescope is the most advanced space observatory ever built. After more than 2 decades of engineering, setbacks, and perseverance, it now floats 1.5 million kilometers from Earth, unveiling the deepest secrets of the cosmos and providing us with images such as the infamous pillars of creation. Webb Telescope was designed as a successor to the Hubble Telescope. Rather focused on infrared vision, it allows us to see the heat and glow of the universe, revealing hidden, distant, or extremely cold objects that Hubble cannot. The telescope has 3 main goals. See the earliest galaxies. Webb can detect ancient light from the universe's first galaxies that is just arriving to our position, allowing us to see galaxies formed millions of years ago. Study exoplanets. Webb analyzes atmospheres of distant planets, identifying gases that could indicate habitability or even life. Watch star formation. Using infrared vision, Webb peers through cosmic dust clouds to observe stars and planets being born. As NASA astrophysicist Amber Stroughton put it, Webb is not just a telescope, it's a time machine. In order to achieve these goals, Webb had to be unlike any telescope ever launched. The massive telescope measures 6.5 meters across, over 2.5 times the size of Hubble's. If you tried to launch it fully assembled, it simply wouldn't fit inside any rocket fairing on Earth. The solution? Webb would fold. Think of it like sending a giant origami sculpture into space, one that must unfold with absolute precision after launch. On December the 25th, 2021, an Ariane 5 rocket lifted off from French Guiana carrying the James Webb Space Telescope. The world held its breath, not just because of the $10 billion price tag, but because this was the culmination of more than 20 years of work from thousands of engineers across 14 countries. The launch itself was flawless. In fact, it was better than expected. The Ariane 5 placed Webb on such a precise trajectory that it saved precious fuel that will now extend the telescope's lifespan from the planned 10 years to potentially 20. Once free from the rocket's fairing, Webb began the slow, deliberate process of unfolding itself in space. Over 30 days, it executed one of the most complex spacecraft deployments ever attempted. Webb was put in orbit in a specific location, the second Lagrange point, about 1.5 million kilometers from Earth. In this place, the gravitational pull of the Sun and Earth, combined with the centrifugal force of Webb's orbit, create a stable position relative to our planet. From here, Webb has a constant view of deep space, while its back is always facing the Sun and Earth. But why face away? Webb's instruments must be cold, incredibly cold, to detect faint infrared light. Any heat from the Sun, Earth, or even the telescope itself would swamp its sensors. To solve this, Webb carries a 5-layer sun shield, each as thin as a human hair and made from a material called kapton, coated with aluminum. The layers are arranged like a stack of offset umbrellas, blocking sunlight and radiating heat away. On the hot side, temperatures can reach 85 degrees Celsius. On the cold side, they plummet to negative 233 degrees Celsius. This extreme temperature difference allows the telescope's detectors to operate with unprecedented sensitivity, effectively turning the cold vacuum of space into a perfect laboratory. Getting to this point was not quick or cheap. Back then, it was estimated to cost around $500 million and launched by 2007. By the time Webb finally launched, it had taken more than 20 years, cost over $10 billion, and tested the patience of both politicians and the public. When Webb left Earth, it was far from ready to take its first image. It had to unfold through 344 single-point failures, parts or actions that, if unsuccessful, would doom the mission. No astronaut could fix it. It was too far from Earth for any servicing mission. Every bolt, every latch, every motor had to work perfectly the first time, and they did. Thomas Zurbuchen, NASA's Associate Administrator for Science at the time, said, I've never been so nervous for a mission in my life, and I've never been so relieved. The James Webb Space Telescope is more than a machine. It is the culmination of thousands of human stories, as Stephen Hawking once said.
It is clear that we are just an advanced breed of primates on a minor planet, orbiting around a very average star. People have prayed for an understanding of the underlying order of the world. There ought to be something very special about the boundary conditions of the universe. And what can be more special than that there is no boundary? And there should be no boundary to human endeavor.